All right, class, this is Mr. Eggleston, and this is the third attempt at doing this midterm review. I had to cancel one of the questions on the review that's posted in the sense that it was just a complicated question, too complicated for the time period, time frame. So I took it off this one, and I'm going to put it on, replace the one that you have with this. All of this is taking out one question. All right, so here it is. There's 20 questions on your midterm. The first question is basically graph this exponential. We were studying this at the beginning of in January, and so we are learning how to graph this. And the first thing in graphing this is look at the equation and look at what the horizontal asymptote is, which is the number I'm circling. It's the number by itself. That's not part of the exponential piece that involves the x, and it's plus 2. So I know that there is a horizontal asymptote at y equals 2. So I put a dashed line here. This should look vaguely familiar to you since we did this at the beginning of the school this calendar year, I guess I could say. All right, there's my horizontal asymptote. Then I know the domain of any exponential is all real numbers. I know the range is going to be greater than the asymptote, and the asymptote's y equals 2. So the range is y is greater than 2. That means the graph is going to bend up. So what we're going to do is make a quick little table where I choose x and I calculate y. Okay? And it's not really that hard, because what my x value is going to be whatever makes the exponent equal to 0. So what makes x minus 2 equal to 0? That's going to be 2. So I'm going to put positive 2 in the middle. And then I'm going to choose 1, 2, maybe even 3. Why did I go 1, 2, 3? That was silly. I'm going to go 3, 4, 5. You can even go up to 6, 7, if you wish. But that's probably overkill. Okay, and then I'm just going to do one less because I know the behavior of this graph. So let's calculate this. 2 to the 0 power, because I'm looking right here, I'm putting x equals 2 in, so 2 minus 2 is 0, so it's 2 to the 0 plus 2. That equals 3. So I know that the point 2, 3 is on this graph, and I'm going to plot it here, and it's right there. Then let's choose x equals 3. So that's, if you put 3 in for x, that's 3 minus 2. That's going to be 2 to the first plus 2, and that's 4. So when x is 3, we're at 4. Okay? When x is 4, now that's 4 minus 2 is 2 plus 2. 2 squared is 4. 4 plus 2 is 6. So when x is 4, y, the output is 6. And if we put 5 in, 5 take away 2, again, I'm always plugging it into this expression. 5 take away 2 is 3. So this is going to be 2 to the third plus 2. That's 8 plus 2 equals 10. So when x is 5, we're up here at 10. And if we go to 1, which is 1 to the left of the quote-unquote 0 point, which makes the exponent 0, so that's why I base this off of 0 point. When x is 1, we get 2 to the negative 1 plus 1, which is 1/2 plus 1. Now you use a calculator, which is 1.5. So we know when we're at 1, we're at 1.5. And so we know how this graph goes. It approaches the horizontal asymptote, then it bends and follows these points. All right, and that's how you graph it. You're going to get a point for each of these, and probably 2 points for the graph. To make sure, I'm going to be looking for the correct 0 point, which is the point that fixes everything that makes the exponent 0. And then I'm going to make sure, bends up to the right and bends down to the left. Try to be as neat as possible. Fill in as many points as you can because these are not hard to calculate. All right. Okay, for question 2 is easy because it's an exponential function with a base of 1/2. They want you to write the equation. So y equals the base is 1/2 and it has a vertical stretch of 5. So the stretch is going to be 5. And then it's and has been shifted right 2. That means it's going to be x minus 2 and up 12, which means plus 12. There you go. Multicolored, looks kind of pretty. Pretty easy. All right. Number 3, finding the ending balance after 20 years for an account where $100 has been deposited initially and compounded weekly. Weekly means the number of compounding is equal to 52. At an annual interest rate of 3.7%, R equals 0.037. Remember, you have to write the percentage rate as a decimal. So our equation is going to be the amount in the account equals the principal, which is the initial investment, times 1 plus R over N raised to the N-T power. So plugging in our numbers, we get P is 100, R is 0.03. I like to put a 0 in the ones place, so 0.037. Over N is the number of times compounded, weekly is 52, raised to the N-T power, which is 52, and remember it's for 20 years. So we have to evaluate this. We use our handy-dandy calculator. Now, I try to use my emulator that is like most of the calculators you guys have, but that did not work out so well for me. So what I'm going to do is use Desmos on my well, here, I'll show it to you here. Here's Desmos. It's actually that right there. Okay. So I'm going to kill that. There we go. So that is actually what we're looking for. It's 100 is P times 1 plus, here's my interest rate is 0.037 over 52 raised to the fifth. Oh, wow, that's incorrect. That's raised. I just saw this. Good thing I'm doing this again. That is wrong. I need to go up there and make that. No. Why is that doing that? No. Boom, 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 boom. That's going to be 52 times. You know what? I think I need parentheses. 52 times 20. Okay. And there you go. And you get $209.54. So we get $209.54 in the 20 years. Okay. Now, let me just double check that. Raised to the 52 times 20. That's a small, yeah, no, that's right. Okay. All right, the next one is solve an exponential equation. To solve exponential equations, we have to use the inverse function, and the inverse function is a logarithm. So since we have 3 to the n plus 10 power, I'm looking at this problem here, equals 80, I notice that the base of my exponential is 3, so I'm literally going to go write log base 3 of, and now here's just the 3 to the n plus 10 power, and that equals, I think that's supposed to be yellow, not green. And since I did it to the left, I have to go log base 3 of 80. The reason I'm doing log base 3 is because the base of the exponential is 3. Wrong thing I wanted to do. And they cancel out. So we are left with m plus 10 equals log base 3 of 80. This is just a number. How do you calculate that number? You use your calculadora, and you have to use the change of base. And the change of base says this: log base b of x equals the LOG button on your calculator of x divided by log of b. So you type that into your calculator, and again, I'm going to use Desmos. I'm going to use the Desmos on here so you can literally see me do it. So that's going to equal, I go to, I have used the LOG button. Unfortunately, LOG is kind of hidden on this. It's right there. LOG of 80, I believe it was, divided by, again, go to functions, go down to where you see log of 3. And that gives us 3.988 or 89, 3.989, wrong button, 3.989. And that's m plus 10. So m equals 3.989 minus 10. So using my calculator, I'm just going to subtract 10. Oh, not 0, subtract 10. And you get negative 6.011. And this comes out to be negative 6.011. And that is the value of m that satisfies that equation. Again, we had an exponential. The inverse of an exponential is a logarithm. And we chose log base 3 because the base of this exponential was 3. If the base had been 5, it would have been log base 5. If the base had been 10, it would have been log base 10, which is the LOG button, and so forth, okay? And notice if I did log base 3 of the left side right here, I had to do it to the right. And then we had to use the change of base, which all of this will be given. The change of base will be given to you, so you don't have to panic about knowing that. And we ended up coming up with an ugly decimal answer of negative 6.011. All right, now notice on 5, we're solving a logarithmic equation. Well, the inverse of a logarithm is an exponential, so what we need to do is denude, get this logarithm right here, all by itself. To do that, we're going to add 9 to both sides, and this is going to be negative 7 log base 9 of x plus 2. If we're adding 9 to both sides, I'll write it on top, plus 9, notice that equals 0. Divide by negative 7 because we need to get the logarithm by itself. We get log base 9 of x plus 2 equals 0. Well, now, we did a logarithm to solve an exponential. We have to do an exponential to solve a logarithm. So since the base is 9 of the log, I'm going to go 9 to the power of log base 9 of x plus 2 equals, and if I do it to the left, I have to do the same thing to the right. So I'm going to make this 9 to the power of 0. These kill each other, and it leaves you with x plus 2 equals 9 to the 0 power, which is 1. Subtract 2, x equals 1 minus 2, x equals negative 1. And that's the answer. All right, on question 6, they're asking you to graph the logarithmic function, identify the domain, the range, and the asymptote. All right? So, first of all, for a logarithm, since it's the inverse of an exponential, the domain of the logarithms, this is very similar to the domain of an exponential. So the domain is going to be all x greater than whatever the vertical asymptote is, which is negative 1. That's the domain. The range is going to be all real numbers, okay? And the vertical asymptote is going to be an x equals negative 1. So to graph this, we're going to put a dashed line at negative 1. Boom, 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 boom. And then we're going to go choose the value to the right, like at x equals 0. And you should be able to do this. Log base 4 of 0 plus 1 is 1 plus 1. Log of any base of 1 is 0, and that's equal to 1. So when x is 0, we're at y equals 1. And we have that point. Now, if we go over until, let's see, log base 4, if I go over 3, if I make x equal to 3, 3 plus 1 is 4, and we know what log base 4 of 4 is, at least you should. If the bases match, log base 4 of 4 is equal to 1. And that becomes 1 plus 1 is 2. So when x is 3, we're at 1, 2. And that's good enough to graph this. So we know this graph is going to bend like that and just kind of go off. And I'm looking for, basically, the points I'm looking for on the graph are going to be, did you get this point right? This is the vertical asymptote. It's a vertical because it's a log. So making sure that vertical asymptote's correct, and that came from whatever makes x plus 1 equal to 0. So it's x equals negative 1. And pretty much there's one other point right here. After that, just make sure it looks somewhat neat. Okay? On this question right here, 7, it says write the equation in vertex form. Well, that's pretty straightforward. At least I hope it is. It's going to be y equals a, parentheses, x minus h squared plus k. That's vertex form, which you will have on an equation sheet. The vertex is right here at negative 3, comma, negative 4. So you can write this as y equals a, x, now minus h, and if h is negative 3, it's actually x plus 3. Remember, your x's are liars. Squared, plus a negative 4, which is minus 4. So we have this. Now we need to figure out what a is, the stretching factor. Easiest way to do this is to choose any other point besides the vertex and plug it in to solve for a. So I'm going to choose negative 2, comma 0. When x is negative 2, y is 0. So we get 0 equals a. Oh, I'm sorry. Yeah, no, 0 equals a, and that's going to be negative 2 plus 3 squared minus 4. That's going to be a times 1 squared minus 4, which is a minus 4, and that equals 0. So a equals 4. All right? So now we got a, and we can write the equation. Y equals a, which is 4, times the x plus 3 squared minus 4. And there's your equation. All right? It's not that hard. It really isn't. Okay? You could also maybe, you might get lucky and realize if I go over 1, square it, normally I would only go up 1. But here we're going up 1, 2, 3, 4. This distance right here from the vertex going over 1, and if we go up 1, 2, 3, 4, this distance here is a. So if you can count that off, you don't even have to choose a point. You can just say, hey, a is equal to 4. And you get y equals 4 times x plus 3 squared minus 4. And that's your equation. All right, for number 8, notice, and I'm going to stop at 10 and then do the second half on a second video. So write the equation in intercept form. Well, intercept form is going to be y equals a, x minus r1, which is the first root, times x minus r2, which is the second root. Well, our roots are what makes the output y equal to 0. So these are the two roots. X equals negative 2. That's R1. So R1 would equal negative 2. And R2 will equal 0. So we get y equals a. That's going to be x minus a negative 2 is x plus 2. Because remember, your x's are liars. times x minus 0. So we end up with y equals a times x plus 2. Now to figure out what a is, the stretching factor, we're going to choose another point. And we have two to choose from. We have -3, -9, or 1, -9. I'm going to choose 1, -9. So we got -9 for y times a times 1, because that's what x is, times 1 plus 2 is 3. Okay, so that's -9 equals 3a. A equals -3. Once we got a equals -3, we can write the equation. And this is what I'm looking for. And it's going to be x times x plus 2. And that's vertex form that matches this data. All right? It says, number 9, write the equation of a quadratic with a vertex at 4, -6, and a y-intercept of 26. So this is going to be y equals a. Vertex form is x minus 4 squared, that's the x value of the vertex, minus 6. That's vertex form. Now we need to figure out what a is. And we're going to use the fact that the y-intercept is 26, which means when x is 0, y is 26. We use that. 26 equals a times 0 minus 4 squared minus 6. 0 minus 4 is just -4. Right there. And so we have 26 equals 16, -4 squared, 16a minus 6. Add 6, you get 32 equals 16a. A equals 32 divided by 16, which equals 2. So now we have our equation. Y equals 2 parentheses x minus 4 squared minus 6. And that is your answer. Okay. That was 9. 10. This is the last one, then I'm going to break and make a second video that covers 11 through 20 or so. All right, write an equation in general. Okay, so it asks you, sketch the graph of the quadratic function. So this is in vertex form. We know our vertex is going to sit at -4. The vertex is going to be at -4, comma, -2. Remember, your x's are liars, so if it's x plus 4, it's -4. So we can count over 1, 2, 3, 4, and down 2, 1, 2. So there's my vertex. Now this graph from the vertex is basically going to be, you would go over 1 from the vertex, square it. Normally you would go up 1, but since we're multiplying it by 2, that stretching factor, we go over 1 squared is 1. We go up 1, 2. So we have a dot right there. Likewise, it's over here. By the way, I probably should put my axis of symmetry, which goes right down the middle of where the vertex is. So I could say the axis of symmetry, AOS, x equals -4. The vertex is -4, comma, -2. And I'll write it in general form after I graph. All right. And then notice we went, just like we should, we went over 1 square it. That's 1. And then multiplied by the stretching factor, we went up 2. We go over 2, 1, 2. 2 squared is 4. Multiplied by the stretching factor of 2, we go up 8. 1, 2, 3, 4, 5, 6, 7, 8. And we end up right there. Okay? So that point is right there. Okay? Likewise, I have a point over here. And it's there, and here's our graph. See if it snaps to it nice. Well, I guess not, but that's okay. And there you go. There's the first 10 problems. I will come back and do the last 10.